Hi everybody, welcome to my first ever talk. I'm going to be talking about the Flutter background geolocation package, which I use to make some kind of proof of concept for this presentation. First of all, who am I? I am Louis, currently an intern at GetDriven. I'm also a student at West, studying MCT, which stands for Multimedia Creative Technologies, and I'm specifying in next web development. I've already had some Flutter experience in some courses while studying, and now I'm applying these in my internship. The main task that I've had until now for my internship was making this presentation and this proof of concept to use the geolocation package. Then a little bit more about GetDriven. We're the host of this Flutter Meetup this year. So again, welcome. We provide a mobility platform for personal chauffeurs. So basically you book a ride, someone comes to you and is your personal chauffeur and drives with your car around. Mostly these are students who drive around with your car. We're active in Belgium and Germany, and we have currently a driver and a customer app on the Play and App Store. Now, the thing I'm trying to solve is the background geolocation. Why would I do that? Well, it's to enhance the experience of the customer, basically. The customer would want to see where his driver is. Is he on the way? Is he far from here? Or even if there's a fleet ride, so when the driver is alone in the car, there's no one with him, the customer can see where the car is. It's to prevent joyriding and delays, and mostly enhance the experience of the customer. So what we need is continuous tracking, of course. We always need to know where the driver is. The customer would also like to see the location history on a map, preferably. An option to request the current location, which is not in the proof of concept yet. Didn't implement that yet, but that's also a feature we would like to add. And the most important thing of all, even when the app is terminated, the location will still be active. So a little recap: we have two users, two personas for this proof of concept. The driver, this is the one who starts a ride and therefore also shares his location. And he can respond to the request, to the location request. And again, the app must keep running even when terminated. Then you have the customer. He books a ride and he can follow the driver's route in the app. He can request the current location and view the history, like mentioned before. For this, I wouldn't code this all myself. So obviously we searched for a package. We looked through a few, but we chose for the Flutter background geolocation as the most robust and featureful package we found. The other ones are unmaintained or don't even support background or need a lot of extra coding. This one is quite featureful and easy to use. So the Flutter background geolocation. What package is this? It's a Flutter package, mainly for background location, but also a lot of features next to that. It's built by Transistor Software and actively maintained and used in many production apps. The main features, of course, background tracking, but the package does not only track the location, it also tracks your motion. That way, it only sends location updates when the package senses that the device is on the move. That's also a feature of the package, battery optimization. That way, you don't have that large of a battery drain. It supports geofencing, and SQLite is integrated for persistence when you're offline to later send the location updates. And it has a great integration with the HTTP layer. This is mainly useful for the headless tasks, on which I'll talk about later. And of course, it's cross-platform, both for iOS and Android. Licensing, sadly, it's a paid package. It's closed source, but it's free for development and testing, which I used. And if you pay for it, you have an optional dashboard for analytics and such. So recap why we chose it. It's the most reliable one, and it fits the best in our use case. But like you see down here, we need to do some setup for the different platforms. On Android, these are the files you recognize, the manifest, the build a bit Gradle. You have to do a few things in here, mostly because of permissions. You don't have to manually set the permissions. Actually, the package takes care of that through merge manifests. That's what you have to set up in the previous files. More about those permissions. In the configurement, the location authorization request defaults to always. So this means that the package will automatically do your permissions for you when needed. You can do them manually, but like I said earlier, when you start tracking or you need the location, the package will automatically do that for you. Then we'll go over to live demo. I'll show you guys how the permissions are done on Android mainly. This is the proof of concept. When I want to start a write, it asks for permissions. What permissions does it need? Location, activity, and because of its background location, you need to change this to always to. And then you can start a drive. But before I do that, I'll give some more information about how I'm going to simulate my location, because I'm not moving right now, and I won't be. So I'll be using an app, Loquito. It's the one that the documentation of the package recommends. It lets me simulate GPS movements. I've set it up so that we're doing a lap around the famous Spa-Francorchamps circuit here in Belgium, which is useful for the testing of the location app. The only thing is, like mentioned before, this package does not only track location but also movement. The Loquito app does not simulate the movements, so I have to configure the package manually to is moving is true, so that it thinks it's moving. I'll just start over here. Now you can see we're on the Spa-Francorchamps track. But before that, the configuration of this package. This is the main part actually. Here you can do a lot of things. This is the basics that I used for my proof of concept, purely for Android. On top, the desired accuracy, this part. It's mainly for the headless mode, on which I'll talk about later. The distance filter is set to 0 right now. You can choose your distance filter, of course. This is based on meters, so if you set it to 10, it's every 10 meters you'll get a location update from the package. I've set it to 0 because we don't want location updates on a location-based, but we want the updates to be time-based. So the distance filter is 0 and location update interval is set to 10 seconds, but that's quite inaccurate, so under that I've set to 5 seconds. So every 5 seconds we should get an update. And like I said before, the is moving is true because the app can simulate the movement, only the location. Then it's quite easy. If you've configured the package right, you can just start and stop it. That's what I'll do now. can start the ride. The ride is started, and then you just listen with the on-location listener, and then you get a location update, and then you can do anything you want with it. You can send it somewhere, you can sync it, notify other parts of your code. You get a lot of things from the location update. You can see if a mock app location is being used. You can see if you're in the vehicle, if you're on foot, if you're on bike. But these are the main things that we are sending with JSON. Just location, timestamp, speed, and battery. Those are things that we are using. And then when you listen to that, I'm sending it right now through a map, which updates live on location. So every 5 seconds, give or take, we should get an update. But then, what if a driver just terminates the app, just kills it? I'm the driver right now. Remember the location on the map, the ride we already took. I'll terminate the app right now, and then the headless tasks kick in. This is a special function that runs in the background. And it runs only when your app is completely killed. It's really useful and powerful. You can respond to silent push requests, handle background location updates. You can do persistence data. I'm using Hive right now, but more on that later also. And maintaining continuity in the background. To get back on the config, I said that was important. It still is. When you want to do headless tasks, you have to configure it. Headless needs to be true. Stop on terminate has to be false, of course. And the tracking needs to be started on boot. Then in your main, this code, the code of the headless tasks, can only be done in your main. You have to put your headless tasks after your run app in the main. And before that, you have to configure your headless task. It's quite powerful because you can run things in the background, but it also has a lot of limitations. You can't access any UI. That's a problem that I've had with the proof of concept that I'll talk about later. It can only be done in the main, and you can only register one global headless function. One headless function, but you can listen to multiple events. You have different events. The events I'm using, location, but you can listen to the motion change, to when the app is terminated, or other things. You can do that to a switch case. When you're using a heavy or long-running app, it could be that the OS kills the headless tasks anyway, but that depends on your OS and on the battery states mostly, and it may not be triggered immediately. Let's go back to the app. It's been killed for a while now. When I go back, the state is being held, is stored, so the write is still active. And the location updates were still sent. Actually, they were locally stored and now sent to the customer. But the location updates were still being updated when the app was terminated. That's the main catch. And that's all because of the headless tasks. Now, in iOS, we don't use headless tasks. It's done another way. The app actually runs in the background, so the full app runs in the background, but that's all iOS magic. So the app sleeps when closed, but it runs in the background, so any significant location change will wake it up, or timely based every 15 or 30 minutes. Then the app quickly sends location and goes back to sleep. The user experiences almost nothing from this. He gets a blue dot, and the location updates are less frequent because of iOS. That also means that the battery impact is minimized, of course. There's not such big battery drain. But when the app reopens, the updates become real time again. Now, this package supports a lot of different things, like I said, the HTTP and the SQLite. But I used a few different packages for this proof of concept, just because we're already using these packages in our main apps. It's meant that I will be implementing this proof of concept in the get-driven apps. So I'm already using these, but you certainly have not to use these. Only Loquito may be a useful one. The other things I haven't used but are quite useful in this package are the HTTP layer. This makes sure that you can upload all your locations, you can batch upload them, you can retry, and also put custom JSON messages. I had to create a model, but this is all done in the config too. This is very powerful, can do a lot of different things. I haven't used this, but I will certainly do this in the future when I'm updating the proof of concept. This also fits in quite well with the SQLite persistence, because what if a driver goes through a tunnel, or you're losing your mobile data? Then the SQLite kicks in. This is standard in the package. It's implemented. So always your location updates are being stored. You can always get them back, and even order them or limit them in how many you want back or are being stored. This is also being done in the config. Almost everything in this package is being done in the config. The main thing is also you can change things in the config even when you run the package. Like, let's say you want to detect if a driver is going on the highway, so he's going at high speeds. If you're detecting high speeds, you can put a distance filter to 100 meters or 500 meters, so you're not getting that many location updates. The challenge I faced is we're using Sandbird, the Sandbird SDK, the chat SDK, but I couldn't send the location updates with Sandbird in the headless tasks. So that's a problem, something I mentioned before. The headless tasks, they are powerful, but they are limited in what you can do. So the best thing you could do is set up an HTTP backend. That's what I'll do next for this proof of concept. First of all, the request location from the customer. Middleware backend, so the application sends through HTTP the location update to our own backend, which then sends the location updates through the official Sandbird HTTP, so that the token is not used in the application. Some improvements with the background response. UI polish, we're using the battery and speed in the JSON, so why not even show it? And of course, the main task, what I'll be doing for the next week in my internship is integrating this into the driver app. Everything mentioned today will be over here. The documentation for the package, my repo, if you want to see the proof of concept that I made, and this presentation is also in there. It's a Mono repo, and a link to the Loquito. If you have any more questions, feel free to hit me up via the Slack or via GitHub or something else. And my only question is, does anybody else have some questions for me?